Hi everyone. First of all, thank you for joining us today. My name's Natalie and I'm here to balance out all of the nerds on this couch. But really, what we're doing here is we're discussing what's coming next for serial production in metal additive business cases in automotive. And who better really to talk about this than Ralf Frohwerk, Alexander Braune and Simon Merkt-Schippers. We had such great success last time talking about aerospace and the path to certification, and people really want to know the ins and outs of this industry and this tech and how to get there and how to elevate their businesses. So this time we're here, and before we get into business case evaluations and the present and future of additive and automotive, I thought we'd just introduce ourselves to the guys sitting on the couch with me and ask them about what they think.
Hello, and welcome to Meet the Makers Automotive. My name is Alexander. I'm the application expert for automotive. In this role, I'm working closely together with sales and business development on our customer projects, and I'm more or less covering the technical part of it. And I'm coming from the automotive industry, so I worked several years for a Tier 1 supplier before I joined SLM Solutions. And I'm happy to be here and looking forward to the session today.
My name is Simon. I'm very happy to be here with you all together. I'm leading the product management team here at SLM Solutions. So my role is to make sure that our products fit the automotive industry. We'll talk about that a bit later. I'm 10 years in Metal AM and I'm looking forward for the session.
Yeah, also welcome from my side. My name is Ralf, Head of Business Development. I have a little expert team coming from the industries. So it's coming from the aerospace, the energy, the healthcare. Me personally, I take care about the automotive. Spent more or less my business life in automotive only at Tier 1 and Tier 2. In regards of our activities, our roles of business development at SLM, we really have to bring the newcomers to the technology. But then it's coming to the jobs working with the customer, identify business case, hand over to Alexander. And what is coming more and more, and that is really great news, support the customer on the whole supply chain to scale it up for serious production.
I mean, Ralf, in your position and your work and with your history, you're in the perfect place to talk to us now about the current AM landscape. Do you want to give us your view on that?
Yeah, I'm very happy to do it. Because, be honest, ladies and gentlemen, we might be in one of the most challenging time in automotive industry. Learning, however, every risk has a chance. And we see that mobility vision is changing completely. That means not only in automotive, in general. And we see that mobility goes additive. But this revolution requires makers and teams, make it happen. But mainly, it needs a business case application. Where we are today, good news first. We are in the industrialization phase. Hey, great news. What it means? The OEMs in the Tier 1 are on the road to go with AM in serial production. There are already some in serial production. Fantastic news. What are the goals for industrialization in automotive? And maybe not only for automotive, but special for automotive. First of all, productivity related to part per cost. Quality, safety, but what we learn more and more, AM design with added value. And that is really key to drive it in this way. In the last years, we raised up already a good confidential level of the PDF, of the powder bed fusion process in general. And in the last 5 years, the machine provider did their job to develop and to launch higher and higher productivity on the SLM technologies themselves. And now it's important, and we come back later to this, We as a machine provider understood the, let me say, not discussable request from automotive industry for reliability, process, robustness, safety, and the need to get the process certified to the automotive quality standard, which is the IFTF 6949. And that is really a challenge. I'm coming from automotive. What it means, job done. Okay, maybe some will say, hey, not perfectly, but most of the jobs is done. And then it means first metal parts and serial production on luxury car programs. Hey, that is great news. And that is normal in the automotive market, that automotive started with innovation, new designs in this, let me say, lower volume car program. And the luxury cars is perfect for this. What it means finally, we set up the bars on the road. Or let us say, the bars on the highway to speed up metal AM. What is the message for today? Let's start, let us do it together.
Yeah, that's really good. I want to highlight one thing. So additionally to this luxury car program, OEMs and Tier 1s, they're also using motorsports and F1 to test new technologies. And I think for us, that's really important because they are pushing the limits, right? And this is what we need in this industry. Someone who's pushing the limits, and this enables new applications for the future, which makes street cars more safer, more efficient. Mm-hmm. And besides that, I think when we're coming from the motorsport or F1, it's always a really good reference when we bridge that into serial production or let's say standard car manufacturing.
Yeah. Yeah, it's pretty exciting.
Motorsport is so important currently, a good driver also for the AM. You're absolutely right.
Yeah, of course, I also love motorsports. I love working in AM and with automotive. To be honest, it's sometimes very, very challenging. Yeah, the whole automotive industry is very lean, very efficient. It's all about cost per part. It's all about cycle time. We come to that a bit later. So the good thing is working with automotive industry, if we succeed here with our machines, we can more or less catch up any business in the other industries and find business cases there as well. I've been in many projects with automotive customers. They give us tough challenges. You need to have balls and courage to work with these customers, to face the problems, to implement the right measures in the products to solve and overcome these challenges. But it's very rewarding in the end if you make a big OEM, a Tier 1 supplier happy and see the machine running and producing great output.
So it sounds really like a huge collaboration. This is the first thing. But I want to dig a little bit into the challenges because two-thirds of you, Ralf and Simon, have mentioned challenges. And I would like you to explain them a little bit more and sort of tell me and the audience how AM is enabling companies to get over them or solving some of their problems.
Yeah, I mentioned this already. I spent more or less my whole business life in automotive. And what I learned is every revolution, and AM is a revolution, no doubt about it, absolutely no doubt, had their time slot. And the learning was every time the same. Take it or lose it forever. And so when I go back a little bit, how often I had really a chance to participate on new developments. Yeah. In 20 years, I'm happy to say I participate on 2 really brand new designs in automotive. And before I joined SLM, I was very proud to say I have 2. Today I have a little feel where customers come up, or here Alexander and the team every week with one. Hey, fantastic. But what I would like to say is I see currently 2 great opportunities to bring AM on the street and speed it up. Based on the conversation, what we have with our OEMs in Tier 1, I have to say global, not only in Europe, not only also in Asia and so on. We see currently in high pressure, let me say in high need, on the OEMs to launch in a much shorter time new models, new upgrades to strengthen the market position. And everyone is aware what currently limit the OEMs, the tier ones, to do it faster is the huge investment in their production line because they are looking for a return of invest. So, and there's where we see AM could enable OEMs to realize flexible production lines with a much shorter invest, which gives the opportunity to have a much shorter return of invest. And to better understanding how it's come, we can eliminate high investment with long lead times. That is also a topic. Let me say in the production line in automotive, whether it is die cast, stamping molds, welding molds, fixtures and all this. Stop to do it, print it right now. Wow. So this is the one topic, really to speed up new models, new upgrades. But you need ideas, you need innovation to speed something up. And that's coming to the other topic, what I would like to mention. Can you imagine what happened currently in the automotive? And beyond, again, I'm 25 years in automotive. A completely revolutionary powertrain. More or less all OEMs globally commit on their way for e-drive. Wow, what it means. Completely new design, completely new production line and powertrain. And they will scale it up in the next year. And my message here is, let's do it today with AM.
Yeah.
Don't miss this chance today, because if this common production methods are implemented, could be too late for new ways with AM.
Yeah. Ralf, are you able to summarize the new vision for mobility? Because it sounds like as these companies are going and driving into the future, everything's changing. A new vision is also working with that. Can you tell me a little bit about that or summarize that?
Yeah, I try to summarize it a little bit in this way. For me, it's today to think totally different in the way how we produce, whether body and chassis or powertrain. What it means, develop of a production environment for a flexible and cost-optimized production of components for next generation mobility. And we're talking about next generation. Let's have a look on the economical and automated production from batch size 1, which is also very important in automotive. And finally, work out flexible production line to extendable, adjustable, and exchangeable.
Yeah.
And that is my vision, or our vision, not my, automotive vision for the new production line.
And I mean, business case evaluations, which we come to, are a big part in identifying these needs. And they're also paving the way for tier 1 and OEM suppliers, right, to tap into that, to this future. But I really want to know, I know a little bit, but not as much as you, what actually is a business case evaluation?
Yeah. So, so maybe I can explain that. So, the main target of business case evaluation is basically to find the return of invest. So, to be honest, no one will invest in a technology without the proper return of invest. And for us, it's very important that we join these projects, these customer projects, in the early stage possible, so that we understand the driver and the motivation behind these projects. This is really key for us. And because it can be different drivers, so it can be cost-driven, design-driven, time-driven. And if we understand that, we can consult our customers in the best way. And if we do these projects, we have our process and the application to go through this business case analysis together with our customers.
Okay, so on that, it would be interesting to also understand the process of the business case evaluation. Could you break that down a little bit?
Yeah. So The process depends a little bit on the case itself and on the customer. That's why we have to be flexible on our process internally. So to nail it a little bit down, so 3 main steps. So step 1 is screening. Step 2 will be the business case analysis. And step 3 will be a benchmark production. And to explain this a little bit along one case study, we selected for today this case study it's coming from the company Eteplan. This part is basically just they call it Y connector. So it's connecting 3 pipes. This is used in a robotic sander. So all this dust is running through these channels. And while I'm explaining this process, I will always come back to this business case so that we have a proper understanding what we are doing here. So what I mentioned, step 1 is screening. So first thing first is we have to understand the motivation and the driver, what I mentioned earlier. So what is the motivation behind that? Time-driven, cost-driven, design-driven. And after we understand this, we will also do a quick check on the design itself. So just for feasibility, we will check the part together with the customers. We will talk about the function, what we have to consider when it comes to orientation and nesting. And this is basically just a quick check on the part itself.
I mean, it's kind of interesting how often does something come into your desk that you have to reject, where the part's just not equipped to go into this AM process. Does that happen?
That's
sad.
Okay. It's a really good question, and so I cannot tell this in numbers or something, but I think most of the OEMs and Tier 1s they know exactly what they want to achieve with additive manufacturing. They know the capabilities, and so they are coming up with clear expectations. But sometimes we still have designs that are not ready for additive manufacturing, or let's say it's not doesn't make sense to produce it in additive manufacturing. Let's say it like this. So what we can do there in this stage, we can consult our customers. We can screen their portfolio together. We can find the right application to get the first step into additive manufacturing. So this is something we can support our customers.
Yeah, of course. Yeah.
I would like to make a comment because your question is absolutely right. And I think the learnings when we go in contact or the customer goes in contact with us is really that very often the customer comes from the vision, use it to being fast. Yeah, and that is a great opportunity, particularly in the development stage, to don't have this lead time for tools, you can print it. And that is really a huge advantage. But be honest, that is not our goal. Our goal is that's what Alexander showed here. We want to go deep, very, very deep in the design. And I can remember the reaction from the customers as we launched our new NXG and we show this e-drive housing was more or less finally AM designed with a huge of advantages. 10% lighter, cooling channel integrated, more stiffness, and a lot of functional integration, part integration. That is our goal. That's what we want to go with the customer. And that is really create the benefits in the end.
I agree totally. And to come a little bit back to this process itself. So after doing this quick check on the design, we also have to collect all the requirements regarding mechanical properties, and we have to talk a little bit deeper with our customers to collect all these informations. And for example, for Eteplan, the goal was basically reducing the cost for the manufacturing, and we also have to consider and talk a little bit about the demand and timing. So what I mean with that is, so some customers, they have a clear different shift models. They have single shift, they have three times shifts. They expect that every build job is ending every morning so they can do the unpacking every morning. And some customers expect exactly 78 parts per month or something. So we have to consider that for the business case. And after we did all the screening, and we had our first talk with the customers, and that was for Etteplan basically that we have a high output of the parts, so basically a full load, maximum output. We will basically go into the business case analysis, which is basically step number 2. And this is finally where we as application engineers start our, let's say, normal job. So we will check the part, we will import the part, we will orient it, we will nest it, we will generate supports. And when we are doing this, we always review the design of the part itself. So when we are trying to orient the part, we also always consider the function of the part itself, for sure, but also what it means in terms of the process. And that's why I like this Etteplan case study so much, because we were able to stack one part on another, so which was enable us to have a, let's call it 3D nesting of the parts, which tremendously changed the business case. And we had a tremendous output. For this specific example here, we were able to put 150 pieces, and we were able to put on a 280 pieces per build job. So this is changing the business case tremendously. And once we set up, let's call it this scene here, and we collect and select the right parameters, we will do a build time estimation to get an understanding how long this process will need. And after we have all our values and informations, we will basically feed our business case analysis tool, which at the end will deliver our customers an idea about the total cost of ownership, which finally then give them an idea about the return of invest.
Let me elaborate a bit on what the role of the customer is here, because Alexander's always saying we, and we really means the customer and the SLM team together, because many, like the cost per part really depends on the customer itself. Yeah, one example is operator costs. Yeah, are different around the world, from a high wage country like Germany to some other areas in the world. Yeah, powder purchasing costs are different if the customer purchases the powder directly from us or from a supplier. Depreciation duration is different for different customers. The shift model, as Alexander said, can be different and can determine a lot the cost per piece. So it's really a collaborative action and joint project with a customer to nail down the cost per part and come to a very detailed assessment about total cost of ownership. And then it's a very easy, let's say, decision for the customer to go into the next phase with us and ask for a benchmark.
Okay.
And I love to add a comment. And be honest, sorry for this, sometimes old man has to speak about history and past and so on.
Yep.
And the learnings, also what I had in my automotive life is, you have great ideas as a supplier. You want to bring so many added value in, but there is something extremely important. The magic started in the first second. That means we kindly ask the customers, the teams, to involve that, to bring Alexander in this game in a very, very early stage. That is the only chance to make all this great success happen. So, and that is also a wish from us and an offer from us to be a partner from the first minute.
Yeah.
And this brings us to our final step. So step 1, screening. Step 2, business case analysis. And now step 3 will be benchmark production. So in the last step of the process, we have to come to make a decision. So let's say we produce a benchmark. So therefore, we have our application center. In our application center, we have all machine types available, running on different alloys. And we will basically print exactly this business case, what we checked in the earlier stage. We can also place specimens on the customer needs, tensile strands, to check density, roughness, different material properties. And we will print that, and we will also deliver together with the parts a quality report called the part production report, which includes all the mechanical properties, a GOM measurement, and all the values from the process itself. And yeah, to summarize this a little bit for this Etteplan part, so we did a lot on this, and we could talk a half an hour about this for sure. But just to give you an idea, we had 3 advantages. So one was cost advantage. So we were able to reduce the manufacturing cost compared to traditional manufacturing by 40%, which is huge. We had a higher efficiency regarding the weight, so we could reduce the weight by 50%. And we were able to improve the flow characteristics in the channel itself. So that's why I like this case study so much. And I hope this gives you an understanding about our process a little bit. But yeah, feel free to contact us anytime.
Yeah, I mean, at the end there you talk about design, and that brings up something I think important and interesting for this topic, that design is a really important element for people to reach further places. And we can't really talk about design without talking about free float and how it enables new applications at maybe a better price. Who wants to take the stage here?
I can take this because I'm
really
really proud of this product that we have recently launched. So free float is our support-free printing technology. So it enables to produce overhang features up to 5-degree overhang without supports. So it really changes the game here. So less support structures mean less manual rework. So in the end, we can significantly decrease the cost per part with free float. But free float has also more advantages. It gives also new additional geometric freedom for internal structures that do not require support anymore. The special scanning strategy is also stabilizing the melt pool, so we can produce very filigree structures like these ones from heat exchangers with a high reliability and a very fine detail resolution. So very important for these kind of applications. And in the end, it's probably a great tool for Alexander, if you know how difficult it is to remove titanium inconel support structures from these parts, how manual it is still, and how cost and time consuming it is, you're very happy if you don't need to do that.
Simon explained it very well, and I just want to add 2 main things. So one for sure is design. So it enables new kind of designs. And as an application engineer, we always have to think about, okay, do we have supports on the inner side? How can we remove the support? How can we access these supports? And with free float, we don't have to think about that, right? Okay. And besides that, we also have, like Simon mentioned, a huge advantage regarding timing in the post-processing as well as costs, right?
Okay. So what are the key requirements on Automotive to make it run, and the things to really realize the business case?
Very simple question.
Yeah.
So it's there's one word that sticks to my mind here. It's overall equipment effectiveness, OEE. I think everyone from automotive industry know this word. And what does it mean? It means, or typically is between 0% and 100%. And if you are at 100%, then you produce only good parts as fast as possible with no stops, right? So this is the idle state. Typically, you never reach the 100%, but our joint goal with the customers is to be close to 100% with our machines, with the factory of the customers, with the production lines of our customers. And if we are close to the 100%, then for sure cost per part looks very, very nice. Cycle time looks good. So a key metrics and a key process or key performance indicator of a good production line, and that's relevant for additive manufacturing SLM technology as well. This is the key requirement, I would say. Above everything is for sure safety. So every production line needs to be safe for an operator. This is plays above everything. And what's also important is quality. So what I mentioned, to produce only good parts mean that you need a consistent quality coming out of the machine. So that's very important. And also the documentation of quality is key. For this, we have SLM Quality. It's a software suite where you can track the key process variables. You can create an automatic build job report of the build job. You can document it and can check out the quality of the parts. Yeah? So again, quality, safety, availability is key here, beside cost per part. On top of this, other requirements are now regarding Industry 4.0 to connect the machines with manufacturing execution systems to come to a very lean and efficient production. On top of this, we have key requirement is that the machine is very modular, and also the interfaces are machine agnostic. So most of our customers have mixed machine parks, so maybe also AM machines from other vendors, and they want to have the right interfaces to run all the machines smoothly together, right? So I would say these are the key requirements, but above everything is really the overall equipment effectiveness, and this is a key metrics I stand for here at SLM. And I'm always, if I talk to the engineers here, everything that we need to develop need to add value and help to increase the overall equipment efficiency of our machines.
Yeah. I mean, I'm really also interested about what role the products play, and where do they fit into automotive?
For sure, the machines are important, but they are just one factor of a production line, an automotive production line. I think our products, like Free Flow, that fits perfectly to automotive industry. There's more than just Free Float. We have invented multi-laser technology. We work with multiple lasers on aluminum alloys with high laser power, 700 watt and more, which enables a high productivity and in the end is creating a lot of cost benefits. So our machines in general are also very scalable. You can go from a 280 to a 500 and then on an NXG 12600 if you have a higher demand in parts and a higher demand in terms of productivity. So the transferability between the machine product lines that we have is given. And I think now with the NXG 12600 and that amazing build envelope of 600 times 600 times 600 millimeters, one of the world's largest build envelopes, we now can fit probably 80 or even more % of all automotive applications in our build envelope, from the powertrain, body and chassis parts. So we've also overcome this limitation and see already great examples like the engine housing that we have already manufactured on the NXG 12600.
I would love to add a comment. That is extremely important because build envelope size is for all industries a key question. But when I see really, as we started on automotive, first of all, of course, in powertrain. And on an NXG, let me say, it's easy, you can fit its V8 cylinder block in. But what's coming more and more, and you mentioned this, thanks Simon, and thanks for this, body and chassis. It's really currently a key application, suspension arms and so on. And for this, it fits well, this build envelope, also the 800 size and so on. It's important that the machine provider has the right envelope, build envelope for this such kind of application.
Okay, I mean, I have to say it, you guys are making it sound really easy though. So far it sounds like, oh, just push this button and put your car in and you have a, but there must be gaps in the technology and gaps in everything. And I'm really curious, where are the gaps there? What is the reality? Like, this is one reality that it is great, it's futuristic, but
Can't we stay in our reality for now?
Yeah.
Yeah, so maybe I can start. I think it's most of the time we are facing that we are compared to standard manufacturing,
Yeah.
and that's totally fine. But the designs are not, it's not designed for additive manufacturing, right? So we're receiving a die-cast design, and we have to print it like this, and we will be compared to a die-cast process. And to be honest, it's just unfair, right?
Yeah.
So this is most of the times the case. So I think there's a lack of redesigning. So we have to successfully implement all the benefits of additive manufacturing regarding design, lightweight optimizations to really get a high advantage there, right? So we have to integrate everything to have a proper business case. It's like, for example, driving an AMG, but only using 2 gears, right? It's, so we have to combine everything, and then we have a proper business case, and then we can compare this to other manufacturing.
Okay.
Yeah. To add on this, for sure, also on the product side, there are gaps, or we call it gaps, or say we can improve our products still for automotive industry. Although we have great examples already where our customers, OEMs, tier 1 suppliers are producing parts in serial production on SLM machines. But we know we are not perfect yet, and we are consistently improving our products. So one example is automation, but modularity, providing the right interfaces. Powder handling is still a nightmare, right? The customers receive the small plastic bottles and somehow need to get it inside the machines, and they need to blend powder, mix powder. So this is something we are working on to improve this and make it also, let's say, ready for serial production. So there's a lot still to do, but we are working on this and we have a solid roadmap. But if we change the perspective, I think there's also a gap on the side of our customers in their corporate culture, especially for the OEMs and tier 1 suppliers who are there for hundreds of years doing their car business and now are faced to a big change, as Ralf said, the electrification of the vehicles and then new manufacturing technologies like ours. So, and I think it's important that our customers don't stick to their comfort zones. They start, let's say, designing the parts more radical. And to be honest, many OEMs are pushing this responsibility towards the suppliers, right? Yeah. And I think this will not work out. It's again a collaborative project between the OEM, the tier 1 suppliers, SLM solutions, and only if all the three work closely together, it will work, right? And so I want to give the ball a bit back to the audience here, as it's not only on SLM if we continue to succeed in automotive serial production with our technology.
Yeah, but Simon, you are described it perfectly, and also the challenge for sure. And that is the offer. What I mentioned at the beginning, a machine provider, as we or the other, we have to listen. Yeah, we have to listen to the gaps and needs. And for example, we are talking a lot about the process themselves, the powder bed fusion process, the SLM process. But there is a huge supply chain from the pre-processing to the process themselves to the post-processing. And you mentioned this, automation is currently a challenge. We have to, because at the end, the interfaces from one production step to the next, yeah, there is no gap allowed, let me say, because at the end, also this whole process have to be certified to 6949. So a cooperation with the OEMs, with the tier 1, with the whole supply chain is key to make it run.
I mean, that's really interesting. And I feel that we had also a guest who was going to come and wrap something up with us also with business case evaluations.
I'm so glad to say that we have a little guest here in our show. A little bit the history, how it's come. we're talking about mobility, and everyone, I think, could understand immediately we're talking not about automotive only. Mobility in general, the change. We used already the word mobility goes additive. And most of all of you know that there is a network cluster. Yeah, mobility goes additive. And the managing director, Stefanie Brickwede, I had a call with her last week, and we are working on the next huge project and so on. And then I came up with the idea, hey, Stefanie, is there any chance to give us a little bit your ideas how mobility go additive? And secondly, because as you know, she's coming from the Deutsche Bundesbahn, and she has also to motivate the internal customer, the external partners to work on AM business case. And I said, hey, what kind of ideas did you create to motivate it? And here's a statement from Stefanie.
Okay, nice.
Hi Ralf, thank you so much for having me and the organization of this really interesting event. You've learned a lot about automotive so far, and I would like to speak to you about some other aspects of printing parts for mobility. I'm not only the head of MGA, Mobility Goes Additive, the network, but also I'm responsible for additive manufacturing at Deutsche Bahn, the German railway provider. And there we started 6 years ago, starting with a top-down approach to find the brilliant use cases all around rail. But if you try to analyze your systems and your data, you need really specific data, and that was how it turned out a bit of a problem. So we changed the whole approach, and we did it with a bottom-up one. And there we asked our colleagues in the maintenance sites and also started an employee competition to find out what are the daily challenges, what kind of spare parts are really missing, and also causing a standstill of trains or also infrastructure. And we discovered a very, very broad range of different parts from different technologies, materials, and also, of course, use cases. And we didn't want to do this on our own, so this was the start of Mobility Goes Additive, the meanwhile leading AM network in Europe with more than 130 member companies. And those cover the whole supply chain of additive manufacturing. And with those partners, we realize our spare parts, which we've discovered, and do this usually in rail, not with a different design, because we are just a maintainer of trains, and then we would have to undergo the whole certification process. But this will definitely be a huge task for the future when we bring in additive manufacturing in new trains. And what might be also a bit interesting is that there are other mobility sectors like the aero and space guys who really try to find totally new designs. They do topology optimization at its best. And this is why we founded a working group within the network to learn more about such use cases. And if you should be interested in learning more about rail, mobility in general, or even aerospace, please don't hesitate to contact either Ralf or me. And thank you again for your attention, and see you soon.
Maybe we can get Stefanie on one day to actually talk further, because she has an immense amount of knowledge regarding AEM business cases also, and what she's doing with Mobility Goes Additive. But I mean, in the past, today, we've talked about the past, we've talked about the current landscape, we've talked about business case evaluations. I want to know about looking ahead and looking into the future. What's on the horizon for automotive when paired up together with AM?
Let's say easy say, future is now.
Yeah.
Because again, I'm sorry for this, that I'm talking so much about the history and the past and so on.
You're an old man.
But can you imagine what kind of revolution we are in automotive currently in the design and in the production methods? yeah, what I explained already. Can you imagine this whole autonomous driving and so on, what will have influence to all kind of vehicles, not only the passenger cars, to the buses and everything. So there is a huge opportunity by this new request in totally different mobility, totally different design, to give an answer with AM. There's another point, and I don't know who from you is currently looking or waiting for his new car. Take maybe a little bit longer based on a little supply chain break. And we have a global supply chain, and I see also AM can enable OEMs and tier ones to bring it more local. Yeah, that can help not to have this extremely big problems, not to deliver very expensive car missing a little chip. So we have a great opportunity currently in the future, and also future is today, it's now, that the customers learn more and more to use AM in a different way, not only with the current materials, also with AM dedicated materials. It's the next great chance to implement AM. Back to another question. Sometimes I was asked, hey, Ralf, we have different kind of production areas in automotive. Where do you think it could fit in the easiest way, AM technology? And the answer for me is very simple. It's the cars industry. Because what is key requirements in automotive? It's timing and cost. And when I see the casting area, for example, they normally split in 3 areas, where there's a prototype area, the low volume, and the high volume area. And to be honest, on the high volume area, we struggle a little bit to be competitive with AM. But this is this lower volume, whatever it's low, hopefully it's increased dramatically in the next. But I see currently business casing running to say what Simon mentioned, the total cost of ownership. Yeah, when you see how much it's cost to implement a production line for a lower volume with a die-cast mold, which is very expensive, and produce then only 1,000, 10,000 parts per year. And there, let's work on this. Yeah. On the other hand, prototyping, for me, time to be market is key. Sometimes OEMs and tier ones waiting months over months to get a prototyping tool to make 20, 30 parts. Stop it, print it. So die-cast industry is really a great opportunity. Finally, let me give you, out of my vision, a good example. And there is one example, I would say, which fit well to all our discussion. Changing design, changing production line, going totally new ways. As you know, we have this strategic customers divergent. And I'm so happy to be also a little bit the leader of this. I started with Kevin and the team in 2015. And Kevin, sorry for this, but when you see how this team started with this idea to make body and chassis in a totally new way, what it means to print not elements and combine it with carbon fiber. 2015, it looks not so nice, maybe a little bit ugly. But do you remember the launch of the Kevin Singer C21 in 2020? Fantastic customer car, fantastic design, and that is unbelievable. And what I would like to say, I'm not only a fan about sport cars and fantastic design. Back to my comment before, the opportunity to change production lines completely. The climate change is by far the most serious issue facing the world today. Absolutely no doubt. We have to work all together to reduce CO2. And we need strategies for this. And I'm pretty sure that this production system, which eliminate really all this production of tools and die-cast tools and welding tools and all this, go directly to print it, that can reduce the environmental impact of a manufacturing line by printing the parts directly. So I think we have good examples. Let's do it.
Yeah.
Yeah, I want to highlight one thing that Ralf mentioned was Divergent. So in my point of view, their production system is really benchmark. So you want to check that out. What I want to say, and Ralf mentioned it, we're in die casting. So we have the same materials, for example, IC10MG, what we are using in die casting also for additive manufacturing. But today we see, and I think we're just scratching a little bit the surface here. So really materials just for additive manufacturing, right? Fine-tuned for additive manufacturing. And I mean, we are talking about aluminum alloys for high resistant temperature, high temperature resistant alloys. And I think this will definitely change the future. And I want also to say that additive manufacturing has always a place in the future. So additive manufacturing don't care if it's a green fuel, e-drive, hydrogen, it doesn't matter the power unit. There is always space for additive manufacturing to add value to the products of our customers.
It's very hard to add more things to what Alexander and Ralf already said, but the future of AM and automotive is bright as long as we do our homeworks. I have mentioned already how important OEE is, and this is something we drive, and we will not give up until we are perfect here and close to the 100%. And because I'm a certified lean manager, I hate waste, losses. So OEE is really also my personal key metrics, and that's why I'm pushing our whole 530 people here at SLM Solution to give everything to reach that goal. On the other hand, it depends not only on SLM, it depends on the customer, on the collaboration. So again, please, audience, please, tier 1 suppliers, tier 2 suppliers, OEMs, be more radical. Use the chance, the opportunity, which is here today and not later. Don't give the stage to all the startups that have to start from scratch, creating production lines. Yeah, they do it. If you are not fast enough, they do it. They take the market. But I think there are so great OEMs in Europe, Asia, and also in the Americas that should do their job and enhance their product lines with AM. So do it now, otherwise the startups will do. I don't care if we work with startups or OEMs or tier 1 suppliers. We love all customers here, so the future is bright. Let's work on it together.
Okay, so business case evaluations, go back to it. They seem like a kind of logical and pivotal bridge to bringing automotive companies closer to an AM reality, right? Lots of benefits, a few challenges, a few gaps. What is the urgency? Why now?
What is the urgency? I would say, as you know, we are very positive talking here, and you mentioned this very often, it's all easy.
You mentioned that, Ralf.
Yeah.
I didn't. Okay.
But be honest, we are all realistic. Also, AM is not plug and play.
Yeah.
And it's need a little bit learning on the design, on to handle the process. Yeah, we have the experts, and we try to reduce this learning curve. But it's important that everyone say, I have a great idea, let's do it. Yeah, it needs a little bit of time at front. So what it means, if you don't start today, you miss the chance to start a project tomorrow because it needs some time. But yeah, the team is here. We see us not only as a machine provider, we want to work on your solution. And on the other hand, and Simon, you mentioned this, and we are on the same page. Sometimes for me, sometimes it's difficult to understand that we have great lighthouse customers and lighthouse projects, and we have customers who years over years in AM already successful in production, and we have others who are really in the starting phase. So, and that is why we think we all have to work together to motivate everyone to start, to make it happen. The potential is huge.
Yeah, so for the question, what is the urgency? So I think future production must be flexible, and I think additive manufacturing enables flexible production and the sustainable production. So for the future, we have to react faster on market trends or changing markets, and therefore, what I mentioned, we have to be flexible. This word again, sorry. But I think additive manufacturing also backing up a little bit the supply chain, that's for sure. And yeah, to summarize it, start with additive manufacturing today, and you will be prepared for the future tomorrow, right?
Hey, thank you. I feel like I got a really great overview on a lot of things, and I realize now that business case evaluations, I don't know, they seem like a sure way, a really solid way to get companies where they need to be. And I'm sort of interested to know more about it as we go on. But I think today it's been a really great talk. And I want to say that we're not doing a question and answer round today. However, Ralf and Simon and Alexander, they're all here to answer your questions. And they write in English as well as they speak in English. So if you want to write to them, you'll get a reply. So anything you want to know about that process, how to make that first step, just feel free to do that, to get in contact with some of our experts and learn how you can drive your business case forward. Yeah. I want to thank you all for joining me today.
Thank you, Natalie.
I've learned a lot.
Thank you so much.
Thank you. Thank you.
Thank you.
Thank you. Goodbye.
Thank you so much.
Goodbye.
Bye-bye.
Ciao.
Bye-bye.